Hello guys, you're welcome to today's exposition. Today we're going to be looking at Proven 8. It's been a wonderful time working on this series, Proving the Divisibility of Numbers. So quickly, before we dash into Proven 8, how do we get to know if 8 will divide a number without a remainder or if there will be a remainder? So the basic you always go through, which is the must-have. These are the things you must have for you to understand whatever we have to take today. The first is basic division knowledge. So if you don't know how to divide numbers, it's very, very important to go through that. If this is the first time you're going to be going through this very channel. So the next is 100% concentration. So if you don't concentrate 100%, there's no way you will get 100% understanding. So here's the logic for 8. 8 is 2 times 2 times 2. It is 3 2's that make up 8. And don't forget, when we worked on Proven 2, we said something that for us to know if 2 will divide a number, you have to check the last digit. So how many last digits are we going to check? Last digit, last digit, last digit. You're going to be checking the 3 last digits for 8. So for us to know if 8 will divide a number, the very, very least number of digits that very given number must have should be at least 3 or 4 digit. So for me to know, or for us to tell if 8 will divide a number without the remainder, the very given number, that very given number that has been divided by 8 should have 3 or 4 digits for seamless proving. But for numbers that have 2 or 3 digits, the very first thing you have to check is if 2 or 4 can divide such a number 100%. Then you can now give attention to such a number to see if 8 will divide it without a remainder. So here's the logic. Testing 8 is more accurate for 4 or more digits because the last 3 digits are brought out and tested with 8, just according to the proven. Note that if both 2 and 4 can't perfectly divide a given number, there is no point testing 8. So it's very, very simple. If you look at a digit that is about, or a number, I beg your pardon, if you look at a number that is about to be divided by 8, and you find out that 2 and 4 cannot perfectly divide such a number, there is no point using 8 to divide such a number. It means 8 will not go. If 2 and 4 will not divide a number perfectly without a remainder, it means 8 also will not divide such a number perfectly. But if 2 and 4 can perfectly divide such a number, then you have to bring out the last 3 digits that such a number has and use your 8 to test it. So look at this. Prove 2324 divided by 8. How do I get to know if there will be a remainder after 8 has divided 2324? So the first thing I have to look at quickly is this. Can 2 divide this number without a remainder? How do you get to know for 2? For 2, you check the last digit. Yes, 2 can go. 2 and 4 is 2. Can 4 go? How do you get to know if 4 can go in a number? You check the last 2 digits. Bring out 24. 4 and 24 is 6. Yeah. 2 and 4 can go. That means we can carry on with 8. So for 8, how do we get to know? Bring out the last 3 digits. 324 divided by 8. 324 divided by 8. I will carry out my 1-on-1 division here. 8 and 3 is 0. Remainder 3. 8 and 32 is 4. 8 and 4 is 0. Remainder 4. It means there will be a remainder. So what does this mean? It means that even though 4 and 2 can divide a given number, it does not mean that 8 will divide such a number. So for you to tell if 8 will divide a number, bring out the last 3 digits. So let's divide. I'm going to be dividing 1-on-1, 1 digit at a time. 8 and 2 is 0. Remainder 2. 8 and 23 is 216. Remainder 7. 8 and 72 is 9. 72. The remainder 8 and 4 is 0. Remainder 4. So it's as simple as that. When 8 divides a number, bring out the last 3 digits. But if the number is not up to 3 digits, is not up to 4 digits, just a 3-digit number or a 2-digit number, as I said, use 2 to check first. Then after that, use your 4 to test. If 2 can go and 4 can, if 2 can go or 4 can go, it means there is no point using 8. It means 8 won't be able to divide such a number also. So let's look at another example here. Let's see. Test. Let's see if 8 will be able to divide this number without a remainder. 1072 divided by 8. 1072 divided by 8. When 8 divides 1072, will there be a remainder or not? How do I get to know? Now, I said the first thing you have to do is check if 2 and 4 can go. If 2 and 4 can go, it's not a license that 8 should be able to divide such a number without a remainder. You still have to bring out the last 3 digits. But if 2 and 4 can go, that's a go ahead that use your 8 to test the last 3 digits. So can 2 divide this digit? 2 can go in this. 2 into 2 is 1. Yes, 2 can go in the last number. Okay, let's see, can 4 go? How do we get to know if 4 can go? Bring out the last 2 digits. Okay, 4 in 7, 1. Remember 1. 4 in 12 is 13. Is 3, I beg your pardon. So 4 in 72 is 13. So 2 and 4 can divide. Then we can use our 8 to test. If 2 and 4 can divide a given number, there's no point using 8. But 8 won't be able to go also. So bring out the last 3 digits. 072 divided by 8. 072 divided by 8. So I'm going to divide. 8 and 7, 0, remainder 7. 8 and 8 is 0. 8 and 7 is 0, remainder 7. 8 and 72 is 9. So 8 and 72 is 9. There is no remainder. It means when 8 divides this number, no matter how big the number is, if 8 can divide the last 3 digits, it means there won't be a remainder when 8 divides the main number. So let's do our division 1 on 1, one at a time. 8 and 1 is 0, remainder 1. 8 and 10 is 1, remainder 2. 8 and 27 is 3, 24, remainder 3. 8 and 32 is 4. There is no remainder. So that's how to get to know if 8 to divide the number. Bring out the last 3 digits and use your 8 to test it. So yeah, a couple of questions I would love us to tackle. Just leave in the answer in the comment section for me. Tell me if there will be a remainder or not when 8 divides this number. So test this. 51104 divided by 8. 51104 divided by 8. Tell me there'll be a remainder or not. Then tell me there'll be a remainder or not when 8 divides this number. 2345 divided by 8. 2345 divided by 8. So leave your answers in the comment section. I'll see you in the next exposition. If you find this resourceful, please click on the subscription button and share this video.